Okay, determine the general solution in radians of the equation sine x equals 0. So, we've talked about how the sine of an angle is r. It's a measure of your vertical position. Sine is 0. That means that we are right on the x-axis. We have no vertical distance at all. And that happens in two places around the circle. It happens right here at 0 degrees, or I'm sorry, 0 radians. We're supposed to speak radian for this. It happens over here at 180 degrees, or pi. Then it happens again at, if we go all the way around the circle back here, we end up at 2 pi. And if we kept going around the left, this point can also be thought of as 3 pi, and so on like that. You end up getting all the direction and get numbers minus 2 pi minus 3 to satisfy this. So in general, if you have 0 pi, 1 pi, 2 pi, etc., you keep writing out those numbers for the rest of your life and say that's the general solution. But if you have better things to do, the compact way to write this is to say that x is n times pi. And we're going to say that n can be any number that's like 0, 1, 2, 3, 4, or also minus 1, minus 2, minus 3, minus 4. And the way you do that is you say n is an element of not the real numbers, but the integers. I is the symbol for the integers, and it means any number with a non-fractional, with no fractional part, positive or negative. If we do this for cosine, we get something pretty similar. You remember cosine is x over r. It's your horizontal position. So if we're looking for places on the unit circle where our horizontal position is 0, that would mean we're either right up here or right down here. Those are the places with 0 x coordinates. And the angles there are, this is pi by 2, and this is 3 pi by 2. And if we kept going around the circle, we'd get 5 pi by 2, and 7 pi by 2, and 9 pi by 2, and 11 pi by 2, and you could keep going like that forever. And also you could go in the negative direction, get minus pi by 2, minus 3 pi by 2, and a whole mess of negative angles. Now, if you look at these, we start with pi by 2, then we get pi by 2 plus an additional pi. That's this one. We get pi by 2 plus 2 additional pi's, and plus 3 additional pi's, and so on like that. In general, the solution is always going to be pi over 2 plus some number of pi's. And to finish that out, you would say that that n number we mentioned should be some member of the integers. So you don't even have to give two lists in this case. Just starting at pi by 2 and then advancing by pi's, you can cover the numbers at the top of the unit circle and the numbers at the bottom because they are evenly spaced, and the even spacing is multiples of pi.